Hello and good day everyone. I am Subere from the SECE 3A, and in this video, I am going to briefly discuss to you the three types of antenna, which are the Yagi-Uda antenna, the loop antenna, and the slatted waveguide array. So let's proceed to the first type, which is the Yagi-Uda antenna. So it is a parasitic linear antenna array which consists of one driven element, one parasitic reflector, and one or more parasitic directors, all supported by a central boom. The frequency range that this antenna operates is around 30 MHz to 3 GHz, which belong to the very high and ultra-high frequency bands. And the inventors are Hidatsugo Yagi and Shintaro Yuda. So the reflector is placed behind the driven element and is 5% longer than it, and the director or directors is approximately 5% shorter than the driven element and is placed in front of it. And the spacing between them is ranges from 0.15 to 0.25 lambda. And the driven element can either be an ordinary half-wave dipole or a folded dipole. So let's say, for example, that an antenna operates at the frequency of 200 megahertz. So its wavelength will be 150 centimeters, and therefore the length of the driven element is half the wavelength, and it will be 75 centimeters. And then the length of the reflector will be 5% longer, so it will be 78.75 centimeters. And then the length of the director will then be 5% shorter and will then be 71.25 centimeters. And let's say that the distance from the DE to driven element reflector is 0.2 lambda. It will then be 30 centimeters. And the distance from the driven element to the director is 0.15 lambda. It will be therefore 22.5 centimeters. And the applications of the Yagi-Uda antenna is mostly used for TV reception and used for point-to-point ultra-high frequency radio links where a single frequency application is needed. So now let's proceed to the second type of antenna, which is the loop antenna. So it is a wire antenna made of one or more turns of wire on a frame, which can either be circular, square, or rectangular, which carries radio frequency current. So its size is very small. In fact, its diameter is even less than 1/6 of a wavelength, operating within the ultra-high frequency range from 300 MHz to 3 GHz. So the classifications of the loop antenna is a small loop antenna when the length of its loop is equal to the 1/10 of a wavelength, and it is considered as a large loop antenna when the length of the loop is approximately equal to a wavelength, where L is of course the length of the loop. So this is a circular loop antenna. So if its circumference is equal to 1/10 of a wavelength, it is considered as a small circular loop antenna. And when its circumference is approximately equal to its wavelength, then it is considered as a large circular loop antenna. And these are the dimensions of a large square loop antenna in terms of wavelength. So the wavelength will be divided into 4, which will be then the sides of the square loop antenna, and one side will be divided into 2, which will be then 1/8 and 1/8, and therefore the cable will be connected to their center. So a small loop antenna its construction is simple with small size and weight, and it has low radiation efficiency due to high losses, and it has lower radiation resistance. While large loop antennas are also called as resonant antennas, and they have high radiation efficiency. And the advantages of the loop antennas are its compactness, wide bandwidth, and sharply defined radiation pattern. On the other hand, its advantages is poor impedance matching, has very high resonance quality factor, and its applications are it is suitable for portable applications such as radio direction finding to locate radio signal sources, and small loops have poor efficiency and hence are mainly used as receiving antenna at lower frequencies. So, the third type of antenna that we are going to discuss is the slotted waveguide array. So, this is what it looks like. So, slotted antenna arrays used with waveguides are a popular antenna in navigation, radar, and other high-frequency systems. So, as you can see, it comes in different sizes, and it allows to propagate signals to a number of smaller antennas or slots, and each of these slots allow a little of the energy to radiate. Slot impedance and resonant behavior for a single slot are dependent on slot placement and size. So the slots here are typically thin, less than zero point 0.1 of a wavelength, and zero point 0.5 wavelengths long at the center frequency of operation. So the slots are in a linear array pattern, and the total of all the radiated signals adds up to a significant power gain over a small range of angles. The slotted waveguide transmits its energy using horizontal polarization, which is of course the best type of polarization for distance transmission. So this is the circuit model of slotted waveguide antenna. The waveguide itself acts as a transmission line, and the slots in the waveguide can be viewed as the parallel or shunt admittances. The distance between the last slot and the end, which is D, is often chosen to be a quarter wavelength. So, the transmission line theory states that the impedance of a short circuit quarter wavelength down a transmission line is an open circuit. So, if D is quarter wavelength, then it will be an open circuit, and this will be its equivalent circuit now. So, the applications of this type of antenna is that slotted waveguide antenna arrays are used in radar, communication, and remote sensing systems for high frequencies. So that would be all. Thank you for watching my video, and see you again next time.